Alright everyone, my name is Eli Fideli. I'm the administrator for HomebrewProcessors.net. In this tutorial I'm going to be showing you how to maneuver and figure out the layout of Xcode, which is Apple's principal IDE, or Integrated Development Environment. In layman's terms, this is what the average programmer codes in. This is going to be part of a tutorial set on how to write a simple iOS app. I originally did a series on my website, again, HomebrewProcessors.net, on how to do app development, but that's text. Plus I can elaborate and include more of my own musings and thoughts and tips and tricks by voice and by actually showing you through a video. So let's get started. Let's open up Xcode. And as you see, when it comes up, there's nothing that much going on. It's a simple welcome screen. This is one of my chief complaints about IDEs in general, is that there are times when I want to scratch out code, real quick, write out a few lines to make sure a concept works, and I don't want to go through the whole creation of a project. One of the principal criticisms of Xcode is that it is the only way to get apps on the App Store. It's essentially the stairway to heaven if you view apps as a gold mine, which most people do. And Xcode is only available for Mac. That being said, on the App Store it's a free download. If you've ever been interested in app development, it's worth a shot to go download and see if you can get some simple things done in it. There's certainly a world of information out there online. So let's create a new project. This is the template. This is essentially sets up your GUI and your class tool chains per an initial template file. Page-based view application allows you to have something that's roughly analogous to the home screen on an iPhone, where there are multiple pages that are concatenated by the initial view frame. Tab, application, utilities. For this tutorial and for its purposes, we're going to go with single view application. Call it, I don't know, Xcode or something like that. Obviously, this is where you select where you want to put the file. Source control, Git repository. This is if you want to create a backup of your source code for version control purposes. Essentially, what version control purposes are is a system, an organized database, if you will, that maintains control over all the different versionings of your program or software. For simple utilities and programs like the calculator we're eventually going to develop, this isn't really necessary at all. It's mainly a nuance for things that are going to be going under multiple different releases, multiple different updates. Like the Linux kernel, for example, is commonly put under version control because it's constantly being updated for nightly builds. So that being said, hit create, and this is what usually takes a while as far as letting Xcode find itself on its initial base, where it creates the files and it indexes them and goes through all its individual quirks and figures itself out, basically. There are three main things in a single view controller that you're going to want to take a look at. The first one is the storyboard. The storyboard is essentially your window, if you will. If you've ever programmed for Microsoft Visual Studio, then this is the form concept. It's analogous to forms in Windows. To loading options, GTK is another windowing API that's commonly used, although neither Windows nor Mac support it directly. Now let's get into the files. App delegate is typically not a file you're going to touch. You're typically not going to really write code here. This is more dealing with how the app interfaces with its environment. So think of this as the app outside of the app, how it wires into your operating system on your phone. It's generally recommended that you don't touch any of these methods here unless you absolutely know what's going on. That's because there's not a whole lot to gain if you don't know what's going on here, but there's a hell of a lot that you can screw up by introducing something that doesn't flow with the rest of your program or with the operating system conventions that are in place. Here's your view controller, and if you've watched my tutorial on C++ development, it roughly works the same way. You have a class interface. In this case, you're creating a version of UI view controller called view controller. And this is the header. So this is where you would declare that certain things exist. In the next tutorial, I'll go into actually how to declare those. And in this video, it just suffices to say that it exists and that this is how it's done. So declarations go in the header, whereas definitions go in the implementation file, which is Objective-C's source code for classes. Over here, down in this lower part of a window, lower right corner, we have our, I forget what it's exactly called, but basically it's your list of objects. Here are all the different objects you can add to a project. So stuff like UI labels can just be clicked and dragged in. UI buttons, which are ways of, obviously you know what a button is, but it's a way of working with user actions. And then there's some interesting things like progress bars, activity indicators, that work more to show you whether a process is in transition, that show you if an action is dynamically occurring. Also in your object corner, if you will, there are a few very highly integrated goodies, if you will. First one is UI image view. This allows you to display an image. Now, to say it's simply an image displayer is kind of belying the point. UI image view is a fully encapsulated imaging object. That is, it will fully handle JPEG, PNG, portable network graphics, bitmap. It will completely handle the process of decomposing the file structure, displaying it, windowing it within. And it can do that all by simply introducing 3 or 4 lines of code to wire an image in to UI image view, if you will. Then you have a text view, which implements a series of scrollable and or editable text that again can be independently windowed of the rest of the view controller. Now we really get into the good stuff, the web view and map view. UI web view and map view are 2 objects that are designed to embed web browsers and map browsers into your projects. These are very highly integrated. If you go to the UI web view tutorial on my website, you will see that you can completely implement UI web view into a project with under 50 lines of actual code to wire it up, if you will, to the rest of the interface. And so at this point, most of the Xcode layout is not as much brute force code. I have done multi-thousand line apps, but more of it is can you figure out how to make it work? Which that is the major challenge, is figuring out how to make your code and the objects that are available to you mesh. These other objects in place, tab gesture, pinch gesture, the gesture recognition objects provide a means for how to interface with user actions that aren't within the context of a UI button or scroll view, etc. instance. GLKit is a not quite dumbed down, but it's a local implementation of the OpenGL protocol for advanced graphics. I haven't quite looked into something that would use OpenGL, but something tells me it's probably going to be gaming environments. That's another place where you would want to use the gesture recognition, because that is obviously games rely heavily on full screen, full window area gestures. Now you're probably wondering what all this up at the top means. Obviously I'm not going to run you through File, Edit, View, Find, Navigate. That's again a gray area. Editor mainly deals with parameters that affect your text editing and your storyboard editing. Product changes parameters on how the app that you're writing will be built. That's why you see run, test, profile, analyze. These are all things that are very important when you actually have a finished product that you want to release or you want to test. Build for changes what happens when build actions take place. And for programming concepts, if you're new to programming, building is the process by which your code is forced through a compiler in a linker stage to actually create the program. Computers aren't going to run your source code. They're not going to understand what at interface means. Instead, they're going to understand long lists of assembly and calling conventions that help merge them into the local operating system. Build for running basically tells the compiler and linker stages to, first of all, compile your source code and then to link the storyboard binary to it, such that it knows that, okay, if you have, say, button 1 in the text and you have a button 1 on the storyboard, it knows to associate the two. I haven't ever played around with source control. I don't even know what that does. If it has something to do with GitHub, then I don't use Xcode for that. I use gedit on Linux, or I use Text Wrangler down here on Mac. There are other things such as enabling that you can, how do I say this? Okay, here we go. It's actually possible to write other things other than Objective-C in Xcode. It's not commonly done, but it is possible. Xcode, as it has been updated and as it has gone through its versions, has become more and more mainlined for Objective-C, iOS, Mac OS X development, such to the point that it only supports on the books C and C++ other than Objective-C. That being said, you can still code in any other language using those other formats. It does support the syntax highlighting for, obviously, as you can see, say Java. The problem in that comes with what happens when you want to build, because there are complex things that need to take place as far as linking the Java compilers and bytecode interpreters into Xcode so that you can actually test. And many people basically take an approach of it's more effort than it's worth. Which this at times gets to me because I want to have an IDE that's more full-featured that I can use across different platforms. So that way, if I want to code in Java one day, I don't have to sit there relearning an IDE just to write Java code, which is one of the main reasons why I use simple text editors like gedit or text wrangler to scratch out code, and then I can compile with the command line. These functions up here, as far as I'm concerned, only one is truly pertinent, and I'll show you why. Suppose you create an item on your view controller, which is a UI button instance. There is a process by which that button has to be linked to code via what's called an IB action. Essentially what this means is that imagine your view controller like a switchboard. Okay, it provides all these ways for, UI buttons, UI labels, all of your objects to interface to you, the user. But just like switches on a switchboard, if the switches aren't wired to your core fabric, the code underneath, then we're not going to do anything. IB actions provide the link behind how the UI button on your view controller is linked to some action that takes place within the code. And the main way that's done is through the assistant editor, which is this little, suit and tie image up here. Now let's suppose, for example, we have a line in here that says oh shit, this thing doesn't like me today. Okay, so now if it decides to stop fighting me, I'm already putting off allergies, but you'll notice that there's this circle or this dot. What this does is this is going to take this line of code, which assigns a UI button, IB outlet, essentially an outlet for code actions, user actions, stuff like that. This is going to assign it. If you click and drag to the UI button, it's going to tell your code that every time you click this button, it's going to send some action, some parameter, something into this label slot. There is a problem is that only using IB outlet, you would constantly have to pull that label to make sure something actually occurred. There is a dedicated other class called IB action, which we will get into when we actually start writing the main part of the app, that provides an interrupt-based handling system for actions. So as soon as you hit the button, then it's going to instantly do X amount of code. It's essentially a localized interrupt service routine, if you have any idea what that means. If not, that'll be it. And more coming in the next segment. Hopefully during the next segment I don't have allergies like I do. Trust me, it's a pisser. Alright, well, stay tuned for the next video.